Milk is one of the most important foods in our daily life. But fresh milk is not always available everywhere. That's where milk powder comes in. And to make milk powder more convenient, more soluble and easier to use, we use process called instantization. Today I'll be talking about the topic instantization of milk. What is instantization? It is a process that makes milk powder dissolve quickly and easily in water, even in cold water. Normally, if you have ever tried mixing regular milk powder into a glass of water, you'll know it often clumps together and takes time to stir. That's inconvenient, especially in situations where speed and smoothness matter. Instantization solves this issue by modifying the structure of the powder. Tiny milk particles are agglomerated, meaning they are clustered together into larger, more porous granules. These granules dissolve almost instantly, creating a uniform and smooth product without lumps. So, in simple words, instantization is about improving solubility and dispersibility, making milk powder more user friendly for both households and industries. Importance of milk instantization. Why do we need this process? The answer is convenience and usability. In today's fast-paced lifestyle, consumers prefer products that are easy to use and save time. Instantized milk powder can be reconstituted quickly without extra effort. But beyond convenience, there are industrial benefits as well. For example, in the beverage industry instantized milk powder ensure smooth mixing in drinks like milkshakes and protein powders. In cold environments or when cold water is used, instantization becomes even more important because normal powders struggle to dissolve. Overall, instantization makes milk powder versatile, practical, and widely acceptable. Milk powder production process. Let's see an overview. The process begins with pasteurization, where milk is heated to kill harmful bacteria. This ensures safety. After that, the water content is reduced by evaporation, concentrating the milk. The concentrated milk is then spray dried. The milk is then atomized into fine droplets and exposed to hot air in a drying chamber. The water vapor the water evaporates quickly, leaving behind tiny particles of dry milk powder. Finally, the powder is collected, cooled, and packaged. This process gives us milk powder that can last much longer than fresh milk, making it a portable and convenient product. Types of milk powder which are commonly seen are whole milk powder, skim milk powder, butterfat or fat filled powder. All of these vary with the fat content in it. Characteristics of milk powder. Now we'll see the characteristics. Moisture content, which is crucial. A moisture level typically between 2 and 5% prevent microbial growth and extend shelf life. Particle size plays an important role in solubility. Instantized powders are made to have larger porous particles for quick dissolution. Fat content varies depending on type. Whole milk has a higher fat, skimmed milk has a very little. Solubility is a defining factor. Instantized milk powder is designed to dissolve quickly, especially in cold water. Bulk density affects packaging, storage, and transport. Because instantized powders have larger particles, their bulk density is usually lower. Other characteristics like color, which is usually off-white or cream, flavor, which depends on fat content, and hygroscopicity, which means the powder can absorb moisture from the air. All of these need to be controlled to ensure quality and consistency. Principles of instantization. The two main principles behind instantization are agglomeration and lacethination. Agglomeration is about forming larger porous granules from fine milk powder. This improves solubility, wettability, meaning the powder can absorb more water more quickly. Agglomeration can be done using different methods. like fluid bed agglomeration, re-wet agglomeration, or steam jet agglomeration. The basic mechanism is simple. The powder is slightly wetted, clusters form, then they are dried and screened to the right size. This the image shows the difference between two milk powders, which one is agglomerated and other is a normal one. The second principle is lecithination. It is a process by which particles of milk powder are coated with a surface active agent such as lecithin. Lecithin is a natural emulsifier. When it is sprayed onto milk powder particles, it coats them and improves wettability. This prevents floating, enhances rehydration, and makes the final product creamier. Lecithination is usually done after agglomeration. Together, these two principles create a product that dissolves quickly and smoothly. Mechanism for lecithination are reducing surface tension, improving hydration, preventing clumping. Methods of instantization. Several methods are used to instantize milk. They are spray drying, freeze drying, roller drying, and mechanical mixing. In this, spray drying are most commonly used. In spray drying, liquid milk is atomized into fine droplets and dried in a hot air chamber to create milk powder. Agglomeration and lecithination are carried out either during the spray drying stage or immediately after. In freeze drying, milk is freeze dried, which involves freezing the milk and then sublimating the frozen water under a vacuum, leaving behind a dry powder. Agglomeration is carried post this process, while lecithination can be carried out during or post freeze drying. Roller drying. In this, milk is spread onto heated rotating drums where the moisture evaporates, leaving a dried film. The dried film is then scraped off and ground into powder, agglomerated or treated with lecithin afterward to improve solubility. Mechanical mixing. This method uses mechanical mixing or tumbling to combine fine powders into larger agglomerates. The powder is mixed with a small amount of water or steam, and the mechanical forces help the particles stick together. The powder is then dried. Factors affecting instantization. The success of instantization depends on several factors like particle size distribution, moisture content, drying method, lecithin content, temperature, and overall composition of the milk powder. By controlling these factors, manufacturers can ensure consistent quality and high solubility. Benefits of instantization. Instantization brings multiple benefits. First, enhanced solubility, no lumps, quick mixing, whether in hot or cold liquids. Second, better rehydration. The porous structure allows uniform water penetration. Third, improved flowability. The powder doesn't cake or clump during storage, which make it easy to handle. And fourth, preservation of nutritional value. Especially when methods like freeze drying are used, sensitive vitamins and proteins are better retained. All of these benefits make instantized milk powder an attractive option for consumers and industries alike. Application of instantized milk. It has widespread applications. In the food and beverage industry, it is used in infant formulas, bakery products, confectionery, and dairy based drinks. In infant formulas, solubility and stability of nutrients are crucial. In bakery and confectionery, instantized milk adds flavor, texture, and smoothness. In beverage, it ensures quick and easy mixing. Outside food, it is used in pharmaceutical and cosmetics. In nutritional supplements, it provides high quality proteins. In skincare products, milk derivatives are used for moisturizing properties. It also finds application in animal feed and pet food while it provides protein and calcium for growth and health. Quality control and standards. Ensuring quality is essential in instantized milk production. Quality checks involve sensory evaluations like taste, texture, and color, as well as physical and chemical analysis tests like moisture, fat, protein, and solubility index. Microbial testing is crucial to ensure safety. International and national standards like ISO, FDA, FSSAI, and Codex Alimentarius provide strict guidelines for production, packaging, and labeling. Challenges and future directions in instantization of milk. Even with these advantages, there are challenges: maintaining nutritional value during processing, improving solubility further, and addressing consumer concerns about flavor and texture remain important goals. Future directions include technologies like microencapsulation to protect sensitive nutrients, better agglomeration techniques, and improved lecithin application. There is also research on alternative drying methods and on ways to preserve the creamy taste and texture of milk more effectively. With advancements in food technology, we can expect more innovation in this area. To conclude, instantization of milk is more than just a technical process. It's a solution that makes milk powder convenient, versatile, and widely usable. It enhances solubility, preserves nutrition, and supports multiple industries from food to pharmaceuticals. With growing demand for ready to use, high quality food products, instantized milk will continue to play a vital role in the future of food technology. Thank you for listening.